Now, let us move on to our activity, which will show us how to find out the volume of a sphere. So, to do that, first of all, we'll take a cylindrical vessel, a cylindrical container, or any container like that, and we'll place the container in a trough. Trough is a bowl-like structure which has a flat base. So we'll place the container in the trough and we'll fill the container up to the brim, the exact brim, no space is left with water. So this container is filled completely with the water. Now what we'll do is we'll take different spheres of different radius. So we'll take spheres with different radius. Let's say these are our spheres. Let us mark the radius to be A. This is our B. This is our C. This is our D. Okay. So now we have taken different spheres with different radius. And now what we'll do is we'll place one by one into the sphere. So first of all, let into the bowl. So let into the container, the vessel. So now let me first place our sphere 1, sphere number 1, that is with our radius A. So now when we'll put it in that, remember to put it carefully so that you do not splash out the water, but the water only flows out because we have placed A inside it. And now the water has flowed out, and we know that the amount of water flowed out, the amount of water flowed out would be equal to the volume of sphere, right? Because it is the amount of water that this sphere has displaced, and it can only displace the amount of water which is equal to V if the sphere is placed carefully without splashing out any water. So now that is place the sphere slowly. So now we have seen that the amount of water is equal to the amount volume of sphere. So now take out this water, take the trough, that is take the container out. Now take the water and fill it in a cylindrical marking. That is measure how much this water is. You can take a cylindrical vessel with graduated scale, right? So it will give you about 1 ml or 2 ml, or maybe it can go up to 1 liter. So fill this water inside it and you will get the volume of the sphere. Now I'll say to calculate 4 by 3 into pi r cube, and you'll see why we have given this number. Now just calculate the 4 by 3 pi r cube, but first calculate radius, and you can do it easily by calculating the diameter like this. You can calculate the diameter of the sphere and then half it and you'll get radius. And this, we already know that our radius is A. So we'll put 4 by 3 pi A cube, and you'll find out that this amount is almost equal to this amount. That is the amount of water displaced by the sphere that we have measured, which is equal to volume of sphere. So this number and the volume is coming out to be same. Now we'll repeat the activity again with our sphere, with our another sphere B. Now when we'll do that, we'll find out that the amount of water that we have measured, that is the volume that we have measured, would be same as 4 by 3 pi b cube. And we'll do this activity or this experiment with 2 or 3 more spheres, and you'll every time you'll find out that the volume is always equal to 4 by 3 pi, and this number which is our radius. So we can say that by this experiment that our volume of sphere is given as 4 by 3 pi r cube. Now, volume of a sphere. We have already found out the volume of sphere in the previous activity by using experiments. So now, let us see in a more clear manner that volume of a sphere is written as 4 by 3 pi r cube, where r is the radius of the sphere. This is our sphere, this is our radius, and the volume is given by this. And similarly, a hemisphere would only have half the volume of sphere. So when we'll half into 4 by 3 pi r cube, we'll get 2 by 3 pi r cube. So volume of hemisphere is given as 2 by 3 pi r cube, where r is the radius of hemisphere, like this. Now let us move on to our question. So the volume of sphere, we have to find out that the volume of sphere with radius 11.2 centimeter. To find the volume, we know that the volume is given by 4 by 3 pi into r cube. We'll substitute the value. R is given as 11.2 centimeter. So 4 by 3 into 22 by 7 into 11 by 0.2 into 11.2 into 11.2. Now when we calculate this up, we'll get our answer 5887.32 centimeter cube. So this would be our volume of the sphere. Now let us move on to our example number 18. In this question, it is said that a shot put is a metallic sphere of 4.9 centimeter. So we have a metallic sphere which have a radius of 4.9 centimeter. Now, if the density of the metal is 7.8 gram per centimeter cube. So our density is given as 7.8 gram per centimeter cube. We have to find the mass of shot put. Now we have been given radius and we have been given density. We know that density is equals to mass upon volume. Okay, so our mass is given as density into volume. We are already given density, we only have to find out the volume. So let us find out the volume. Since it is a sphere, so our volume would be equals to pi 4 by 3 pi r cube. So we'll do 4 by 3 into 22 by 7 into r is given as 4.9. So 4.9 into 4.9 into 4.9. Into 4.9. So we have a cube of radius and 22 by 7 into 4 by 3. So when we will calculate this out, we get our answer to be 493 centimeter cube. Now to get the mass, all we have to do is multiply density into volume as it is written. So our density is given as 7.8 and our volume is 493, and when we multiply it we'll get 3845, that is 3845.44 gram, which can be written as 3.845 kg, and this would be our mass of the shot put. So now let us move on to our next question, and that is a hemispherical bowl is given. So we have a hemispherical bowl and the radius is given as 3.5 centimeter. Now what would be the volume of water it would contain? So the volume of water would be equal to the volume of the hemispherical bowl. So now let us calculate the volume of hemispherical bowl, which would be given as 2 by 3 pi r cube. So now it is 2 by 3 into 22 by 7 into 3.5 into 3.5 into 3.5. And when you'll calculate this number out, you'll get your answer to be 89.5 centimeter cube. So this is how we'll find out the volume of a hemisphere or a sphere, and we have learned that how do we find out the volume of various shapes and sizes. Now let us move on to a quick revision of what all we have learned and have endured during this chapter. So first is we have the first part was with the surface area and the curved surface area. So these all were the surface areas formula. So our cuboid was given as LB into BH into HL, and cube is just a special sphere. So we just put in A over here and we get 2 into A plus A into A plus A into A. This is a plus, and we used to get 3a square, and which will give us our answer as 6a square. And then we have our curved surface area of cylinder, which was given as 2 pi rh, and we had done an activity related to it by using a rectangle, and we had measured the length to be 2 pi r, and our height, that is our breadth was h, and the area was given as length into breadth, which would be 2 pi r into h, and this would give us the area of the CSA of cylinder, because we know that when we'll curve it up, when we'll fold it up, we'll get a cylinder, and the CSA would be equal to the area of this page. Now then the total surface area was given as 2 pi r plus and h, and this was done by including the base and the top, that is by adding 2 pi r h plus 2 pi r square, because we had a top and bottom. So we'll get this number by taking out 2 pi r common. Now then we were given the curved surface area of a cone, which is pi rl, and the total surface area of a right circular cone, which was given as curved surface area, this area, which and adding the base area to it, that is this, and we used to get pi r l plus r, where l used to be our slant height, this side, where r is this, h is this, so we used to get it by r square plus h square. Then we have the surface area of a sphere, which was 4 pi r square, and we find it out by activity, that is we swirled around, we wound it around a length of a string around the sphere, and then we filled up 4 different circles of same radius, and we saw that the string completely fills it up, and so we said that the area of all the circles together, that is sum of all the 4 areas, would give us the surface area of the sphere. So we summed it over the 4 circles, and we got 4 pi r square, and the curved surface area of a hemisphere is 2 pi r square, because hemisphere is just the half of sphere, so this area would be 2 pi r square. Then we come out to the total surface area of a hemisphere, which is CSA, which was 2 pi r square, and we'll count the base also this time, pi r square. So we get 3 pi r square. Then volume of a cuboid, L into B, that is the area of the sheets making up, and then height was the height to which these sheets are stacked, h, and this would give us the volume of cuboid, that is area into height. And when we'll have the cube, that is a equals to b equals to h, that is a, we'll get a cube as our volume of cube. Then our volume of cylinder was given as pi r square h, and volume of cone, we did it by activity by filling the sand in the cone and then filling it up the cylinder, and we saw that we have to fill 3 times. We have to fill the cone 3 times to fill up the cylinder, and hence we got the volume of cone. Now the volume of sphere is given as 4 by 3 pi r cube, and we did the activity about by measuring the amount of water that a sphere would spill out, and it was coming out to be same as 4 by 3 pi r cube. We did it by hit and trial. We were testing it out by measuring the water differently, and then using this formula by substituting the value of radius of the sphere that we have used, right? And then volume of a hemisphere is given to be as half of the volume of sphere. So this is how we do the chapter, and we've done this with this chapter. See you in the next class.